Welcome to this video, where we'll see an example of how standards-based statistical workflow management can be implemented using as far as possible off-the-shelf software available on the web. The first standard we'll rely on is SDMX, the reference standard for representing and exchanging statistical data and metadata in the sector of official statistics. The second standard we'll use is BPMN. That is the main standard used in the field of business process management when it comes to representing business processes. Both are open standards and supported to some extent by open source software. One allows representing statistical information, the other allows representing statistical processes. So let's see how we can use them together. As a use case for the demo, a simple process will be implemented to collect a CSV file from Statistics New Zealand and perform some basic processing and dissemination tasks. Workflow management will rely on Camunda platform, data modeling on Fusion metadata registry, and statistical dissemination on the .stat suite. I'll provide more details about software used in the demo later. Let's start by making a first sketch of the process using Camunda Modeler. In our example, the process will be started manually. The first task will consist of downloading from the web a CSV file with provisional data from the 2021 Annual Enterprise Survey from StatsNZ. Once the file downloaded, it will be transformed to a target SDMX structure used for dissemination. It will then be loaded to a .stat suite validation area where it can be checked before publication. Then some referential metadata will be added. A human validation will be performed for authorizing publication. If the user approves the release, content will be published to a .stat suite dissemination data space. A social media post will then be issued to advertise the release. Finally, a report about the execution of the process will be sent. One more thing will be necessary at the beginning of the process, creating a workspace for storing data and metadata manipulated during the execution of the process. So this is a BPMN process model, not executable yet at this stage, but it already provides a nice overview of what the process will look like. When we talk about processes in official statistics, we immediately think about the GSBPM. The GSBPM intends to cover the overall statistical business process and includes activities supporting process design and process execution. The approach illustrated here supports both sides of the loop between process design and process execution, which is critical in the context in which producers of official statistics operate. There is indeed more pressure on agility and time to market for the delivery of new statistical products. Producing timelier and higher frequency statistics based on alternative data sources also typically requires improved efficiency and repeatability of processes. This is supported by standardization of workflow management as demonstrated here. In our demo, a series of services are necessary. They are all mapped to the GSBPM. The full specification includes also a description of the function performed by the services and the list of required inputs and outputs. Different software used to implement these services are listed in the last column of the table displayed for the moment. To make selected application function available to the workflow engine, some glue code is necessary and will be developed in Python using a module called PyCamunda. From the 8 services required, 7 are web services and consist of executing software. 1 is a human task. A service consists of exposing a function through a specified interface. In the case of the user task, the function is performed by a person and not a computer program, which is not an issue as long as the interface is formally specified. So let's link our BPMN tasks to the services in Camunda Modeler. I'll go through the different activities and use so-called activity templates defined in Camunda Modeler to embed service specifications showed a minute ago. These templates allow linking BPMN activities used in the workflow to GSBPM subprocesses and to services. They also hold the list of expected input and output parameters with descriptions and default value when relevant. So setting up the process workspace maps to GSBPM overarching subprocesses and we'll call the service named init workspace. Here will provide the identification of the SDMX data flow that will be updated by the process. Downloading the CSV file from StatsNZ website will map to GSBPM subprocess 4.3 run collection and will call the service named download web. This service requires providing the URL of the file to be downloaded. Mapping to the target SDMX structure is associated here to GSBPM 5.2 classify and code and will call a service named convert SDMX. A reference to an SDMX structure map present in the Fusion metadata registry needs to be provided here. Loading data to .stat validation data space will correspond to GSBPM 6.1 prepare draft outputs and will call a service named load data. The file to be uploaded and the target.stat data space are provided to the service. Updating data collection date in the reference metadata will be mapped to GSBPM overarching subprocesses and call the service named update collection date. The data flow identifier provided in the first step of the process is reused there. User validation is linked to GSBPM 6.2 validate outputs and consists of a manual task. An identification of the user who will have to perform this task is provided. We need also to set up the gateway to proceed with the next task only if publication is approved. A condition is configured to direct the process flow depending on the value of a variable named validation status that will be set by the user task. We'll see that later in the demo. Published data and metadata on a .stat suite dissemination data space will be a GSBPM 7.1 update output systems and will call the service named transfer data. Default values about source and target data spaces are kept unchanged. Publishing a social media post about the data release is mapped to GSBPM 7.4 promote dissemination products and will call a service named post tweet. A link to the public version of .stat Data Explorer where data can be viewed is used as an input. Finally, sending the process execution report will be linked to a GSBPM 8.1 gather evolution inputs and invoke a service called send report. This last step is not modeled as a BPMN activity, but as a BPMN message and event. Currently, it seems element templates for events are not supported, so this setting needs to be done a bit differently. So far, we have worked on modeling the process. Let's now model the information manipulated by the process. Fusion metadata registry has been used to author different SDMX artifacts required. Source data from the CSV file downloaded is modeled using an SDMX 3.0 data structure where a numeric row index is used as sole dimension. All columns from the source file are represented as measures holding row values in text format. A dedicated SDMX concept scheme is used to hold the list of columns from the source file. The output data structure is modeled with an SDMX 2.1 compliant data structure with a series of dimensions, one measure, and a series of attributes. An SDMX concept scheme is used to provide meaning to different components used in the target data structure. Different code lists are also defined to represent values allowed in some columns, such as the indicator or industry dimensions. An SDMX 3.0 structure map is used to specify the relationship between source and target structures and derive the transformation step performed by the Fusion metadata registry. In most cases, values are transferred as is or are fixed values. In a series of cases, so-called SDMX representation maps are used, for instance, to split observation value and confidentiality level, or to split unit of measure and unit multiplier, which are collapsed in the same columns in the source file used for the demo. Only the target SDMX data structure will be stored in .stat for disseminating the transformed data. It is exported from the Fusion metadata registry and imported in .stat suite using the data lifecycle manager. The process model can be annotated with information objects. So back to Camunda modeler. This is added to the process diagram for documentation purposes and is not actioned by the workflow engine. Actual input-output parameters are set in the different element templates showed previously. The workspace setup takes a data flow identifier as input and returns a workspace identifier that will be used in the rest of the process flow. The download step takes a URL as input and returns the name of the file downloaded into the process workspace. SDMX mapping takes as input the name of the CSV file to be transformed and the identification of the structure map to be used from the Fusion metadata registry. The name of the converted SDMX file is provided as output. Uploading the data takes as input the name of the file to be loaded to .stat and the identification of the target data space, the validation area in this case. Updating collection date in referential metadata uses the identifier of the data flow and of a data space in .stat as input. The identifier of the data flow is available as a process variable set up by the first task. Review and authorization of the publication takes as input a link to .stat Data Explorer to view the data in the validation data space and outputs a validation status that is approved or not approved and is used by the following gateway to direct the process flow. Publishing data and metadata takes the identification of source and target data spaces in .stat involved in the release as an input and outputs a link to the content published on .stat. Posting a notification on Twitter takes as input the link to .stat and returns a link to the post created on Twitter. At this stage, we have modeled what is called the happy path in business process modeling. The example implemented will also handle some errors returned by services and the case data publication is not approved. In such cases, the process flow will go directly to the end event and send the execution report. Some minor additional things need to be configured on the process model in the user validation step for sending emails when a task is assigned or completed and to refer to the form used for data validation. This is the fully detailed process model that will be executed for our demo. Let's now see how this is supported in terms of IT stack. At the level of infrastructure, at the lowest level, a Vultr Cloud Server is used to host the whole sandbox implementation. The operating system is Ubuntu. Docker and Docker Compose are used to deploy and run application components. Regarding network aspects, Certbot is used to create certificates used to connect applications securely over the web. Nginx instance directs incoming web traffic to the different applications. For monitoring, Grafana and Prometheus are used to measure the use of resources by Docker containers and on the host server. Regarding development tools, VS Code and GitHub are used. Eclipse is also used to a limited extent for some specific Camunda extensions, in particular for components handling email notification for user task assignment and completion. As core business applications supporting different services required, we have Mailco as email server. It includes an admin web app and Sogo as a webmail client. Fusion Metadata Registry is used to manage SDMX artifacts. Its transformation service is also used to map collected data to target SDMX structure used in the demo. .stat Suite is used for dissemination. It includes .stat core services, .stat Data Explorer, and .stat Data Lifecycle Manager. Twitter is used also to illustrate the promotion of statistical releases on social media. Regarding workflow management, Camunda platform is used. It includes a REST interface to the workflow engine and a series of web applications, Camunda Admin, Camunda Cockpit, and Camunda User Tasks. Python is used to expose required application function provided by core applications as services accessible to the workflow engine. This makes use of Python virtual environments, PyCamunda, and regular Python modules. Some limited Java components are also needed to support email notifications about assignment and completion of user tasks. Camunda Modeler is a desktop application used on top of this to create process models and deploy them on the execution platform. Regarding licenses of this software, all are open source and freely available on the web. Nevertheless, for Camunda, it's important to note that Camunda Platform 7 Community Edition is used. This version is free to use, but Camunda also proposes a commercial enterprise edition. Camunda Platform also exists in a version 8 available under a software as a service model. Visual Studio Code is the main tool used for setting up the demo implementation. It is used to set up Docker files, configurations, and glue code developed to expose different services. This illustration shows the folder structure used on the server and the Docker containers running for the project. Let's now run the process. So here is our process model in Camunda Modeler. We can start the process manually from Camunda Modeler by clicking this play button and confirming the deployment setup. This little pop-up indicates that a process instance has been started and provides a link to Camunda Cockpit where we can monitor the process. For accessing Camunda Cockpit, we'll first have to log in. Here we see the process instance running. The first tasks have been executed and the process is now waiting for the data publication to be authorized before continuing. On the dashboard view, we see we have one process deployed, one process instance running, and one user task pending. In our email inbox, we have a notification from .stat Suite transfer service saying that data has been loaded. Another similar notification is telling us that referential metadata has also been successfully loaded. We also received an email from Camunda informing about the assignment of a user task. The link here will bring us to the tasks. So let's see in the Camunda user tasks web application what it looks like by clicking the link. The user task consists of a form inviting the user to check the data for which a link to .stat Data Explorer is provided, and to check a box and submit the form to authorize publication of the data release. Let's click on this link to view the data in .stat Data Explorer. As we are viewing content in .stat validation environment, it is necessary to log in as access to this area is restricted. In the .stat Data Explorer, we can see the data table to be validated. We can, of course, also check structural metadata and referential metadata. If the data is okay for release, publication is approved in the user tasks application by checking the box saying that this data may be published and submitting the form. If we go back to our mailbox, we'll now have a notification from Camunda platform saying that the user task has been completed. We'll see a notification from .stat saying that data and metadata have been successfully transferred to the dissemination environment. And as defined in the process model, when the process is terminated, we'll receive also an execution report providing some information on the execution of each step of the process. Here we see the process workspace has been successfully created. A CSV file of 6.3 megabytes has been downloaded from StatsNZ. A little more than 40,000 rows have been converted to the target SDMX structure. SDMX data has been loaded to .stat validation data space. Data collection date has been updated in reference metadata. Publication has been approved by the designated user. Content has then been published on .stat dissemination data space. In the last task, we see a tweet has been posted to advertise availability of the new data. Let's click on this link to Twitter. We see the tweet created by the process with a link. If we click this link, we'll be redirected to .stat Data Explorer. And here we can view the data newly published with its metadata. And all this has been produced by the process. Now some brief conclusions to wrap up. We have seen a possible implementation of standards-based statistical process management, combining use of SDMX and BPMN, also in line with the GSBPM. Domain-specific business logic has been fully specified with open standards used to drive the process, which is executed on a generic and domain-independent platform. This approach is sometimes referred to as metadata-driven architecture for statistical production. We use the free version of Camunda platform to orchestrate a process relying on application functions provided by Python, Fusion Metadata Registry, .stat Suite, and Twitter. This approach supports separation of process design and process execution steps and allows building new processes by reassembling existing functional building blocks. The approach supports also separation of concerns between statistical and IT tasks, which may lead to higher level of quality of developments in both fields. The idea is that standardization of statistical workflow management can help improving agility and time to market when developing new statistical products. It's also a way to make statistical production processes more efficient and repeatable. So that's all for the demo. Thanks for watching.